IoT Specialist Solutions Architect with AWS. And what we're trying to do is reach out and identify developers and the community, kind of targeting initially meetups that are interested in getting more involved and creating a community for IoT development efforts. So today, what I wanted to focus on is introducing you to something that I've been helping one of my colleagues work on, which is we're really working on a customer-facing workshop for using KVS and WebRTC for IoT applications. And so what I'm going to walk you through today is a live build out of actually getting a device connected and kind of introducing you to some of the concepts from an IoT perspective that can help you build end-to-end video-based IoT applications. And so let me go ahead and share my screen here. Is everyone able to see that?
Yes, we are.
Okay, great. Thanks, Patrick. So the point for today is not necessarily to dive into the deep, nitty-gritty details of KVS and WebRTC or even IoT, but to give you sort of a hands-on approach to understanding, again, how to build from the device back through the cloud side. And we are experimenting with some of these formats right now. So any feedback you have coming out of today, we're definitely looking for that, for what was effective, maybe what we can improve on. And then I have a couple of other ways for you to engage with us as a kind of general community after this as well. So I'll go into that. So as I mentioned, there will be a little bit of introductory material. I'm going to go through a live coding and configuration exercise, and I'll explain to you what I'm doing there, with the goal of actually building a connected device that's running just a very simple camera to show you how you can then turn around and integrate that into your own mobile or web applications. So just think about like the Ring, right? How would I go about building my own application like that and bringing that sort of thing to market, maybe using AWS IoT services? That's what we're targeting today. So with that being said, if you have any questions, I am building in time at the end here for us to open it up for Q&A. But if there's anything that's unclear or you would like, to engage with me on while I'm doing this, I'm perfectly fine with you asking questions along the way. The last piece here, just to ask everyone, I understand this is a general AWS meetup and not necessarily IoT specific. Does anyone here today have any IoT experience? Working in these virtual environments, I know it's a little bit tough. So even if you just kind of maybe indicate in the chime room that you do or you don't, that'll just kind of help me understand what level of depth I need to go to in introducing maybe some IoT concepts instead of just assuming that you know all of those. That would be helpful for me to see. Cool. Thank you, Vincent. I see you worked with the ESP32. John works a lot with the Raspberry Pi, and James, same as well. So great. What I'll do then is I'll give you a little maybe light introduction to some of our IoT services. And as I'm navigating through the AWS console, which I thought would be a more effective way than just automating a lot of this, I hope to introduce you maybe some concepts that might be new to some of you as well. All right, so that being said, let me go through this, again, very light introductory material here. This is really focused on developers, but if you're more of an architect or even someone that might be in a what we call a fleet operator type position, someone that might operate a fleet of devices, I feel that this material may also apply to you. And this is very specific to using WebRTC with Amazon Kinesis video streams. And like I said, I'm not going to go real deep on WebRTC as a spec or even how kind of KVS allows for that to be used. I like to be practical and pragmatic, so I'm just going to show you how to go and use it. Through the workshop that we're making generally available to customers with external facing. If you've ever seen, we've got workshops.aws, and we've got a number of workshops out there. We expect this one to be published out there sometime within the next month or two, hopefully, if all goes well. And you'll be able to get a little deeper introduction on KVS, WebRTC, and so on. So really, all that I need to get started, if you have an AWS account, Today, I'm going to be using a Raspberry Pi 4, but this particular set of demo code is designed to be run on, you could run it on your MacBook if you wanted to, otherwise any kind of Linux-based operating system. The sample code, and I'll show you where you can get that GitHub repository after the meeting is over here, is C-based. And so anything that you can run CMake on, you can really port that over. But ultimately, this is just sample code that's useful for you to get up and running and building these types of applications. In a production scenario, if you have any deep embedded and video expertise, you would probably choose to use our SDKs and incorporate that directly into your own applications instead of using our samples, just as a kind of heads up there. And then, of course, we're working with cameras. So you're going to want some sort of camera module. I will say that the SDK has a mode that will run in kind of like an emulator fashion. So it'll generate the live video stream with kind of a fake video feed, if you will. So if you don't have a camera, but you still wanted to get this up and running, maybe while you order a camera to test this out, you could do that as well. So here's the general kind of architecture for what we'll be building. You can kind of see we've got the Raspberry Pi. We have, through AWS IoT Core, we have something called the Credentials Provider Service. And I'll introduce you to that more officially in just a second. But what this allows us to do is really treat the device like an IoT device and use X509 certificates provisioned on the device to call out to AWS IoT Core to retrieve temporary credentials to access other AWS services directly. And that's not exclusive to Kinesis video streams, but in our example, that's what it'll be using. And this would allow you to integrate directly with other services in AWS. It is scoped through IAM policies and all that. So I'll talk about that in just a moment as well. But ultimately, if you had to build a device that you needed to send maybe local recorded videos directly up to S3, for instance, this would be another way of thinking about securely giving that device access to those things with an X509 key pair and device certificates provisioned onto that device, and then scoping its connectivity back to IoT Core via an IAM policy to give it temporary credentials to go and access other AWS services. The other thing here is in this particular demo today, because I'm not actually going to be building a live front end in front of you, we have a web client that can be used to test and view the live video streams in KVS WebRTC in the AWS console. And so you'll see we've got kind of like this persona video stream viewer accessing the stream directly through the web browser in the console. In a real production deployment, we might actually have mobile applications and web applications built using something like Amplify, and all that would look more like this, where the mobile client would be calling out to the KVS service to initialize the stream, and then ultimately your device, and the benefit here of using KVS WebRTC is we can possibly establish that peer-to-peer connection. There's more that goes into it than that if you have to deal with NAT and NAT traversal issues from the network, which the IoT device is running on. And that's really what the WebRTC spec is meant to handle, is all that negotiation of how I can connect and initialize that stream and whether I can get that peer-to-peer connection going or not. But yeah, this might be what it looks like in real life. So the AWS IoT Credentials Provider Service, I thought this would be worth introducing a little more formally. Again, this allows you to use, there's a specific endpoint, and I'll show you how to obtain that, that's different than, say, integrating with our IoT service over MQTT to send up your telemetry or to receive commands from the cloud side down, that is specific to getting these temporary credentials. And if you're familiar at all with some of these other services in AWS, like our STS, which is meant to allow you to get these temporary credentials and have these be scoped to a specific IAM role, that's how this is more or less working under the covers here. And this is all fully documented. I actually just borrowed a diagram here right off of our AWS IoT Core documentation to give you an idea of what's happening here. And so these are scoped basically AWS key pairs that have a built-in timeout. So they're only meant to be temporary, but for like KVS and all that, you'd go through the same interactions you would with any other sorts of temporary key pairs to refresh those and so on. So does anybody have any questions so far, or should we just go ahead and start building? All right, then. So let's go ahead and start to build this. Just so that you're aware, I'm going to be doing a little bit on the device side in an SSH session, so not really interactive in the console in that sense. Hopefully you can see this okay. I zoomed in a little bit here. The only thing that I've done so far on this particular Raspberry Pi that I'm tunneled into right now is I have gone out and ensured that it's connected to the Wi-Fi and that I can actually access the device itself over my own local network. Aside from that, what we're going to do is just start to pull down some things like the actual GitHub repository. And let me show that to you real quick. We have this repo out here. It's out under the AWS Labs organization. And if you're kind of familiar with what we have out on github.com, we have a few different areas where we put sample code and all that. AWS Labs is one of them. There's another one for called AWS Samples, where myself and my team will put a lot of sample code as well. But I'll include this link at the end in a slide that you can reference later on, so that you can go and download this. Most of the instructions I'm going to show you are just verbatim from this, but some of the specific steps that I'm taking are specific to the Raspberry Pi. And so if you were to run this on a device like an Intel, I can't remember what they had, the Edisons and things like that, the steps are going to be very similar. The packages that you might get are going to be specific to their actual device builds. And so you may have to do a little bit of searching just to figure out exactly what the equivalents are. But the tool sets that we use are pretty commonplace. So I'll explain to you what those are and how we think about building on top of those as well. Okay. So just to begin with here, what we need to do if we have a freshly built Raspberry Pi is just go ahead and update the overall environment. Just for the sake of time, I've already also installed these things because sitting here watching someone else install Linux packages is fairly boring. But let's just look at these packages that I've installed so far, right? One, like I mentioned before, we do have CMake. Some of these are just common like libSSL dependencies. The vast majority of these dependencies, though, are the GStreamer plugins. And so the SDKs here that we're using are built on top of GStreamer, open source technology that helps us pipe in local cameras. And we could also use KVS WebRTC potentially to incorporate a GStreamer pipeline. And again, I'm not going to go into a lot of the details there, but you could build a pipeline to incorporate IP cameras, right, that aren't directly connected to the device. That would allow you to build some sort of edge-based gateway that incorporates video streams from multiple places using the same SDK, if that makes sense. So that's another strategy to think about when we think about building these sorts of applications. All right, so really the next thing that we're going to do here is just go ahead and clone this GitHub repo just on the device itself. It is going to do a recursive clone. This will take just a few moments. The nice thing about the Raspberry Pi V4, I got the 8 GB memory model, so it's got a little more horsepower on it than like a Raspberry Pi Model 3. I will give you all a cautionary note. If you try to build this on like a Raspberry Pi Zero or on a Raspberry Pi V3, I think the first time I ran this on a Raspberry Pi V3 or a Zero, it took me like 8 hours just to compile the thing. So it is purely a processing power problem on these devices. There are some configuration options you can do to kind of improve that speed and tune that, but that's just outside of the scope of what we're talking about today. Once this does get cloned, the only other thing that we're going to do is start to actually run the CMake command and let that build in the background. And then we're going to go back over to the AWS console and start to actually configure some of the cloud side resources, including the IAM policies and all that, so that those are all ready, as well as walking through the steps of provisioning the IoT thing. And you can see my my network bandwidth must be fluctuating just a little bit because this is taking just a little bit longer than normal. My kids are home from school, so they're probably hopping on Fortnite and streaming TV and all that. So, all right. So now that this is here, just real quick, aside from a couple other sample projects that I had on this Pi at one point, we have the directory. We're going to be working primarily out of this. And you can see here, there's a whole bunch of stuff in here. Again, this just comes right from the actual demo, or sorry, the GitHub repo that's publicly available. The only thing we're going to do is make a build directory. And from within here, like I said, there is quite a bit of work that's going to happen in the background. CMake itself is also going to clone a number of SSL and other dependencies and build those specific to the hardware. If you were, of course, thinking about building this for production, you would go through the development cycle, perhaps on the device itself, get your build working, get your entire software side of things figured out on the device, build that, and then deploy that as part of like the flashed firmware on the device instead of building it on a device by device basis like I'm doing here. But this is really just to help you with like that initial maybe prototype or POC phase. Something else that I'm working on from a developer advocacy perspective is thinking about going from POC to production and the types of steps that we help customers with in that scenario, including what I just kind of talked about. But this is going to take a few minutes, so we're going to come back to that in just a moment. And
one question: if you wait the 18 hours and build it on a Pi Zero, does the result run well on a
yes.
Can it run well on a Pi Zero? Okay.
Yeah. Actually, aside from that, once the binaries are compiled and all that, it's actually fairly performant. Once you've got things up and running. It's same thing with the Raspberry Pi V3, right? So yeah, while the compile time takes a while, yes, once it's running, it runs very well.
Good, thank you.
So Okay, so while this is running, like I said, this is going to take a little bit. What I'm doing actually right now is I have selected the Ohio region to work out of. Me living in the US Southeast, I typically just work in the Virginia region. And so I'm going to work in a region that I typically don't, just to create all these assets in the cloud for the first time. One of the things I'm going to start with is, as I mentioned before, just creating the IAM policy here. And I'll walk you through this as well so you can kind of understand what we're creating. But let's start here. We're going to create a role. And the role that we're going to create is going to basically have access to the KVS side of things. And actually, sorry, create the policy first and then attach the role to it, just because that UI does have some things in it that make this a little bit difficult. So if I start here, let's do this. Kinesis, you can see KVS is one of the services I can select here. And if I just look at the things that I want to be able to do, just like most IAM policies, we've got this kind of CRUD level access set of higher level policies that I can choose from. There are a couple of things that are KVS WebRTC specific that we're going to need to set here. Ultimately, I'm actually just going to go ahead and paste in an entire policy that I already have pre-crafted, and I'll just walk you through this instead of me poking around and possibly missing something. And again, these are fully documented, so hopefully I don't discourage you from just kind of pasting this in here, because these things are all part of the KVS WebRTC documentation. First of all, there is a little bit of a policy placeholder variable that we allow for here that is unique to our integration with the AWS IoT credentials provider service. And what's cool about this is it allows me to say, hey, if you have an IoT thing that's registered with a specific thing name, yeah, I'm going to allow you to do things like put media, which is one of the core KVS operations, or get data endpoint, or do some of these other things that are WebRTC specific here, but only for your thing name, right? So that allows me to say, hey, I'm going to be a thing, and I'm going to have a specific name that's registered in our IoT registry, and I'm going to give you a policy that allows you to interact with a stream, a video stream, that has the exact same name as my thing name. So that's a convenience aspect of how the interactions work between the IoT core credentials provider service and the IAM policies here. Of course, you could use other policy placeholder variables and so on to further restrict this according to your needs, but I just wanted to kind of point this out. Describe stream, get data endpoints, describe signaling channel, create signaling channel. A lot of these things are going to be abstracted away by the SDK itself, but they're all official APIs. So if you're really good at working with WebRTC and you were kind of building your own version of the SDK around these things and you understood how to interface with each of these APIs, then you could access these APIs directly and all that. So, but these are the minimum policies that are required for a KVS type device to actually interface with the KVS service using WebRTC. From a tags perspective, I don't need to give that anything special. I just need to give the name real quick here. And we're just going to go ahead and call this the KVS IoT camera policy. And we'll go ahead and create that. The only other thing we'll create is going to be a role for that. And here I'm just going to actually select EC2, even though I'm not going to use it. KVS, what did I call that? IoT camera policy, there we go. Add that. And go ahead and click review. Of course, I'm not actually doing this. Allows KVS WebRTC based IoT devices to get temporary credentials. That's basically what we're doing. And the role name here, KVS IoT camera IAM role. Of course, use whatever kind of naming conventions that you're used to working with. The trust identities is the only thing I'm going to have to go back and clean up here. So let's go back and do that. The trust relationship is the other piece that I need to clean up because I just clicked through that. But there's also a piece of this that's specific to working with AWS IoT Core. And actually, instead of being able to perform the STS assume role, again, if you're kind of familiar with how IAM trust relationships work, what you're doing is you're allowing other services to interface with AWS IAM and other services on your behalf. In this case, there's a specific endpoint or a specific service name for credentials.iot, and that's what we're going to use instead. And all this is fully documented in the KVS WebRTC documentation. So hopefully you don't have to go far to find these sorts of things. All right, so once that's set up, that's kind of maybe the more boring part of this setup here. Let's just take a peek here and see we're about 66% configured, from the CMake perspective, so that's still running. Next thing we're going to do is, we're going to go back to the IoT Core service. And in AWS IoT Core, if this is new to a lot of you, there are a few things that can help you get up and running with getting a device SDK and all of that configured. We're not using a device SDK today because we're using the KVS WebRTC SDK for C, and it has some sample code that we're going to put in place to allow it to call out to the credentials provider service. But we do have that, and it will help you make devices very quickly. There's some videos on YouTube about that now too, as well, to show you how to walk through that. What I'm showing you here, actually, under this manage part of the left-hand navigation menu, the manage portion of our console is what we would call our device registry and our device management portion of the AWS IoT console. And we're just going to go through and create a thing real quick. And I could choose to register multiple things at once. We've got bulk registry operations. From a POC perspective, right, we're just going to register a single things. In the future, though, if we have to think about manufacturing and all that, we have support for all sorts of patterns that I just don't have time to go into today. For just-in-time registration and automated provisioning, we have support for all those things. So if you do get to that point where you're really curious about how to take this to the next level, please do reach out. Like, we're interested in having those conversations and at least showing you how you can think about doing that as well. All right, so next, I do have kind of this naming convention from our Raspberry Pis that just make it so that I can easily identify them. Super secret IP address there. But yeah, that's I've got a small fleet of these things on my desk. And so one day I figured out I can't just call them all Raspberry Pi. The next thing here is I could register a thing type. Normally I would do that in production. I'm not going to do it today. I will just mention real quickly here, if you get in here and you're wondering, like, there was a couple of iterations of the service from a device management perspective. And if you don't select a thing type, there are some attributes that you can add. And these are just key pair attributes. If you don't add a thing type, you can only set 3 total attributes. If you create a thing type, then you can have up to 50 attributes. And all of those would be searchable through what we call our fleet indexing service. Again, maybe a little bit more than I can fit into things today, but just wanted to make you all aware in case you kind of come in here and you want to start adding attributes. Like, attributes might be things like, device manufacturer, might be IP address, it might be OS version, it might be the firmware version of the KVS WebRTC sample code that I've got out there, right? Things like that. All right, so I am actually going to go ahead and do what they call a one-click certificate creation. This will give me all the device certificates that I can download, and then I'm just going to secure copy these, SCP these over to my actual device, and I'll do that in just a second. This is one of the easiest ways to do it. So let me go ahead and grab these 3 certificates. And I'll just go ahead and SCP each of these. The name, it's kind of nominal, right? It gives it a name because in the background, these certificates are being signed by a certificate authority that AWS IoT Core provides for you. But ultimately, the last thing I need to do here is activate these. The other thing, by the way, it does tell you this. You need to download the root CA. I just have a quick curl script to do that on the device itself, so I'll wait until I get over there to do that. But yeah, I'll activate these certificates, and off we go. So I'm going to go ahead and click done. The other thing you could do is you could attach a policy, and this is an IoT policy, and it's kind of like an IAM policy, and I'll walk you through that in a second. But you can attach policies to certificates, or you can attach them to what we call thing groups. And I actually prefer to do it via thing groups, so that's what we're going to do next. So I have a device, and next thing I'm going to do is come in here and I'm going to create a thing group. And there's 2 types. There's dynamic and static thing groups, but let's just go ahead. Oh, wrong thing. We're going to call this one a KVS camera devices, and that'll just be my thing group name. I could have some attributes here that I could associate with it, but I'm not going to go into that. What I do want to use here is an attachment for a policy. I have to create the policy, don't I? Let's go do that. Let's come down to secure. There's a number of things that we manage in here, and this is kind of part of our device registry. Let me just walk you through this briefly here. The thing certificates, like the ones that I just registered, that one is in here. I can come back in and I can revoke this. I could come back in and check its overall details, right? So you can see who the issuer was. You can see the expiration date, the effective date, and the created date, all those things. You could actually use your own certificate authority if you wanted to. That's, again, kind of out of scope for what we're covering today. But really what I want to do is create an IoT policy that controls when a device actually makes calls to the AWS IoT core endpoints, what it's allowed to do. So in a sense, it's kind of synonymous to an IAM policy. And again, if this is all new to you and this is a lot of information at first, I understand. This stuff is, again, very, very well documented. You'll even see here we have links right into the AWS IoT policies documentation page. And I'm not trying to give you an exhaustive introduction to this, but I do want you to at least kind of understand what I'm talking about here. What we're going to do here is create a policy, and we're going to call it KVS IoT device policy. And I'm just going to adjust the actual policy statement here just because I have one handy, and I'll kind of walk you through it. And I know the UI does make this a little bit difficult to read, so I'll show you on the next screen what this all says and walk you through that. All right, so let's kind of come back here and look at this here. So first of all, there's a few things that I've done that are just kind of basic AWS IoT best practices. I allow you to connect as long as the thing is attached into AWS IoT Core. The other thing that I'm doing is I'm allowing the devices that have certificates that are attached or associated with this policy to perform this role alias mapping. And so what this will allow the devices to do is use their certificates to call out to the AWS IoT Core credentials provider endpoint and to call a role alias by name, which we're going to set up in just a second, to obtain temporary credentials that are mapped to an IAM policy that'll be mapped to through this role alias. So hopefully it all makes sense once I have it all set up. But the other things this is actually doing is I am kind of setting some generic policies here that allow me to publish or subscribe if I wanted to build a device that is still sending data up over MQTT. I'm setting some kind of basic rudimentary policies right out of the gate that says, hey, you can publish to topics until we come back and say otherwise on a topic name structure that starts with your thing name. It just kind of gives you a basis that may allow you to build an IoT device that has some other needs. So that's all I've set here. Now we need to go back to our thing groups, and I need to associate that policy here. And it shows you the preview of what that policy is. And of course, you could add another policy here, but I'm just going to do the one for now. And it's kind of checking that everything, this is showing you a visual of what those policies are and what's allowed and what's not, from what perspectives, just kind of a visual way to look at that. And then I'm going to go associate my thing with the thing group. So if I click in, I'm just kind of clicking back out so you can see how I get into each one of these things. If I click in add thing, then I'm going to add my thing into this group. So now this thing, because it's within this group, will get access to that policy. So it gives you a mechanism to control access policies from the IoT perspective that way. All right, the last thing I need to set up here is what's called a role alias. And I know I've got a lot of little steps here. Once you get these things set up initially, managing it is much easier, right? You, again, fully documented. You can go and see how all of this is recommended, actually all from the KVS WebRTC documentation. In a lot of cases, you don't even have to go over to the AWS IoT Core documentation. But for completeness, I wanted to show you the steps and how we set these things up so that you can come back to it later. All right, so let's see, what did I want to call this thing? Let's call it the KVS camera IoT role alias. And here we get to actually map to the IAM role that we created earlier. And here we go. I have the KVS IoT camera IAM role that I created, what you looked at earlier, and just create role AOS. That part's really as simple as that. But what allows the device to actually access this through the credentials provider service to basically assume that role through the IAM policy that we set up is through the policy itself and how we set that up in the policy, the IoT policy that is. So in the IoT console, that's really all we had to do. Now this build has kind of completed. What I'm going to do here is the next step that we're going to operate in the background now that the CMake command has finished is we are actually going to start the build of the application itself, just to get some of this going. And this doesn't take really a long time compared to the CMake command before, which was pulling down a number of dependencies and building those as well. But this will take just a second. So while this is running, I need to go and actually find where those certificates went, and I need to start to send those over to my device. So if you'll bear with me for a second. I started with 586, so I need to go find those devices, or sorry, find the certs and get those out onto the device. So I need to send 58. So just kind of grabbing all of those certs, and let's send those out to my Raspberry Pi. And we'll just put it in the home directory on the Raspberry Pi. I'm not doing anything special here, just some SCP commands. All right, so that pushed all three of those out there, and we should be good to go. Actually, just to make sure, let's go look in the home directory on the Raspberry Pi. My certs are over there. Everything worked, so I should be pretty good to go there. The next thing, as I mentioned before, I need to download the root CA certificate. And this just uses the same exact Amazon Trust certificates that all of our services use. There are a few root CAs that we can possibly use to sign things. For these IoT device certificates that I generated, we do use this Amazon root CA 1. So if you go on there, on the Amazon Trust repository, you'll see there's a CA1, a CA2, a CA3, and a CA4. We use the first CA for these specific device certificates. All right, so, oh, I didn't mean to put that there. Let's move that back out to the home directory. And just real quick, I also want to make sure that I downloaded that correct. Cert looks good enough. I typically don't have any problems with that. So anyway, the next thing we need to do, let me actually introduce you now to the sample applications in the SDK, because we're all set to actually go in and start running that. I've built the samples, but I need to come in and start making some changes to that, and I'm going to walk you through that in just a second. But the samples here, just to make you aware, these are what we're working with right now. There's a few of them, including the one that I'm primarily going to be working with is this KVS WebRTC client master GStreamer sample. All that being said, your device is producing the video stream using GStreamer, and this is really what we're working with. But most of the code that we're actually going to adjust is in this common file. And so if I just give you a brief introduction here to kind of give you a sense of what it was like before we start working with it and kind of why they've set it up this way and how we're making changes to allow this code to call into our client, our credentials provider service, you'll see kind of what they've done and what we're changing exactly. So first off, if I just do a search in here for AWS, you'll see there is this function here, create sample configuration. And in here, they're checking to see if some environment variables have been set. And this is like a pretty common way to start out with KVS WebRTC. Is the idea is, hey, you're just going to have a device that's calling the KVS WebRTC, so let's just give it an AWS access key pair. Well, the reason we want it to connect to the credentials provider service is so that we don't have hard-coded AWS access key pairs on the device. And, there's certain reasons from a best practices perspective to use X509 certificates instead for authentication. It's also enabling TLS 1.2 mutual authentication when we go the X509 certificate route. So lots of benefits to going that route. And once your device is also connected to AWS IoT Core, there's a number of other complementary services like AWS IoT Device Defender that can help you with the security and operational monitoring of your device fleet. So just little things that makes it a good integration to start with to integrate your camera-based IoT devices and treat them as IoT devices out of the gates, even if they're never going to send up telemetry. So anyway, all that being said, we're of course going to swap out this use of AWS access key pairs and secret keys to instead use the credentials provider service. None of the other code is really changing. There's a couple of code blocks that just use the variables that get loaded up here, the access key and the secret key. And if you go and look on the GitHub repo itself, back here, you'll see the engineering team that works on this, they have documented how to do this, right? Like I talked about, they've got the policy information, and then they tell you, hey, this is what you might do instead. What they did was they hard-coded the paths to these things and kind of made some assumptions about hard coding the credentials provider service. So I wanted to go just a step further. Since the samples use environment variables for the AWS access key pairs, I wanted to also inject all those as environment variables, because if you've built cloud native applications for any amount of time, everybody injects configuration, right? Isn't that the way we should do it? So that's what I'm going to do. And I have a convenient script. Let me show you how that works real quick here. That will generate just a shell script with all this in there. But first, I need to actually go in and replace some of this code and recompile the application. So I know I've said a lot so far. So while I'm kind of changing directories and getting my next bit of code changes to make in that actual common file, does anybody have any questions about what I've said? Is it clear as mud? Is it too much?
No, pretty straightforward.
Okay, cool.
I've used Kinesis before, so yeah, that helps.
All right, awesome.
So is this pretty much like how a Ring device is protected? It has from the factory, I guess, a certificate, a key that I guess is registered in the Ring network, and it knows who it is. And
so I actually can't speak to Ring just because in Amazon they're a separate business, and I have not had an opportunity to kind of ask them those sorts of questions. But if I were to think about what I would recommend customers do, this is what I would recommend.
Right. Because I guess then the next question becomes, how do you mass produce that? You're making 1,000 of these things. So how do you get and maybe that's the stuff you talked about earlier. You have mass build methodologies and things like that.
Yeah, precisely. So there is what we would do is, instead of provisioning the certs like I just did, there's a couple of different ways to think about doing this at manufacturing time. We could either send down batches of certificates onto the device ahead of time. We could put what's called a birth certificate on the device. And even though it's not ideal, there's another way to do that with like a shared credential, like a shared X509 certificate that's used at device provisioning time to request a more permanent certificate. And actually, that's a fairly complex topic, so I don't want to go down that path right now, but just know that there are quite a few options, and it can support virtually any sort of scenario that you want to. Just because we've now built in a number of capabilities over the past few years from that perspective, due to what customers have said they want from us.
Thank you.
Yeah, so as I am going through this, hopefully this makes sense. You'll see I've just kind of replaced the previous variables. I've added a few more variables up here. I've replaced their error checking to make sure that the necessary variables are actually set. And then the actual next part that I'm going to replace is they had another piece of code called create static credential provider, and it used all that configuration. And I am going to replace this actually with another line. Oops. And all that we're doing here is replacing, they have another function that's kind of built in that allows us to use this IoT credentials provider call to initialize the configuration and all that. And under the covers through the SDK, it's going to call the credentials provider endpoint. All these variables are passed in as environment variables. And so the only other thing I need to do now is, let's make sure this still builds first of all. So I made some code changes. I'm going to go and build it. And of course, there's an error. What did I do? Hang on a second. It wouldn't be a live coding exercise if I didn't actually break something. So let's go back into here and see what I got wrong. All right, so, sorry, what was the error? Make file. If I can't get this to work based on my fat fingering of code, I do have another backup example with this actually working, and I might switch over to that. So apologies. Sometimes the dev team makes small changes in the actual repo. And one thing we're working with them on is, is some better incorporated testing on the AWS IoT side of things. Again, this is just sample code, so we don't intend for customers to treat this as production code. And so it comes with that caveat, right? It's like the Apache 2.0 or MIT license. I can't remember which specific license this repo has. So it does come with some open source caveats of use at your own risk and may not work out of the box right away. So let's do this. Let's actually switch to my other Pi, which has all this working, and I'll show it to you working. Oh, it helps if it's plugged in, doesn't it? So the other thing I'll tell everybody while this is booting up, the worst possible scenario happened while I was prepping for today to come and talk to you all. I was plugging in cameras on 3 different Raspberry Pis, and none of them seemed to be working. And I have 3 different cameras. I have about a dozen Raspberry Pis. And so I almost had to hit the eject button on today, but thankfully, at least it seems these Pis are working. I don't know if it's just that I've finally abused them enough that they are just not responsive in some cases, and that my little bits of hardware aren't working anymore. But yeah, let's go over to this directory here. I'm going to show you a few things just so that you can see what I've changed. Oh, and it's going to help if I make this larger. All right, that should help. All right, so real quick, let's go over to, you can see the changes that I made here. All right, so same exact changes I was just showing you. Again, these are all steps that they are documented in a way in the existing repo. All that I've done is instead of hard coding them, I'm taking them as environment variables, which make this all quite a bit easier in my mind to actually come and work with. The only other thing that we need to change here actually is there's a script that I've generated, and I wonder if that's in here. So I've generated this convenient script because we have to have all of those environment variables that I told you about in there. And so if we just look at this convenient script, it's not doing too much. It is setting a thing name. And this is actually going to be needed inside of the code because the thing name has to be the same as the stream name. And so the KVS WebRTC client master GST sample takes one argument that I haven't exported now as an environment variable, and that's just because this is the standard way that this was built to work. And this is meant to be a KVS WebRT stream name that it intends to create, which is why it needed the IAM permissions to create that. And aside from that, you'll see that there's just a number of environment variables that I've set here as far as like the IoT certificate paths. These things will be loaded in so that it can call the credentials provider endpoint. Here, the way to get this IoT credentials provider endpoint, because this is different than the MQTT endpoint. And if any of you have ever seen that, you can go in the AWS IoT console and you can see this is what we now call the device data endpoint, but we don't show the credentials provider endpoint in here for whatever reason. There's some other new things that we've allowed for, like custom domains that just got released recently. But the way to get this is there is an AWS CLI call that will actually call out to that. So let me just show you how you obtain that. So there's this AWS IoT describe endpoint call. And there's a number of endpoint types that we support. And in this case, it's just calling the type IoT credentials provider. And this will be region specific as well. And you'll see that in the actual endpoint name. This one's for US East 1. If I need to call that out for US East 2, then I would just add the region flag here. And you'll see what the credentials provider endpoint is. For the most part, this this part of the fully qualified domain name should be pretty consistent in your AWS account. But the first time that you incorporate it, I just encourage customers to go ahead and call that endpoint just to make sure. And then from there, you are tying it into a specific region. I've experimented with this where I might call KVS, for instance, in California. There is a little more latency when you're doing that sort of thing, but because we're using WebRTC, and if your local network allows the NAT traversal options to work and allows for the peer-to-peer connection to work, you're still actually going to be getting a very low latency video feed from the device itself. So let's go back here and actually get this set up so that it uses our Ohio region, and that's the only other thing I'll change. So let's come in here, change our default region to US East 1 to US East 2. And I'm just looking at the rest of this config here. I'm going to change actually this one to do this, and I'm going to change a couple of the certificate attributes here to reflect the other certs that we loaded in before. I do have a convenient script to help with this. Like I said, it's just a simple bash script that will generate this all, but that's also the point of me generating the bash script instead of just using the convenient script to launch this, is so I can go in and edit these things. So let me go grab that information real quick. And the other thing I'm going to need to do is send this the certs over to that device. Let's see what else. We've got the private key, the cert. Oops, I need to change that. Private key, pem.cert. That one did end with cert. And I'm going to have to download probably the root CA here as well. Let's go ahead and change that. CA. Most of these certificate names are nominal, by the way. And of course, you can use OpenSSL tools and convert these certificates as long as it's supported in the SDKs that you're using and in the OpenSSL libraries that you're using. That's the only kind of caveats typically. All right, so certs should be here, so that looks good. Let me just pull down the root CA here as well. Okay, and again, just double check that the CA came down. I'm going to do the same thing here. Okay, good. Yeah, sometimes when I'm copying stuff around all over the place, a little network interruption can ruin your day when copying these things, which is another reason to get into some of these other things like fleet provisioning and all that. All right, let's see if this thing's going to run. Let me just make sure I got the name right for this guy. Yeah, I got that one wrong. Certificate. Oh, I included CERT. Okay. The other thing to note here is I used an old role alias name. I forgot to note that as well. So the other thing is we are passing in the name of the role alias that we want to map to. This is just something that we have to do. And so let's go grab that role alias name in the IoT console. It crashed, basically. What we saw was the device failed to connect because it was trying to connect to KVS using the credentials provider service. A little bit of a nondescript error there. All right, so some of the things that you're seeing here look like failures, but actually some of these things are just initializing for the first time. So these are okay. What you're seeing here is important, though. It's creating a signaling channel for the Raspberry Pi for a certain name. And I can actually check this. Oops, why is the browser not coming back up? Here we go. So now if I go over to KVS, in this region, you can see there's a signaling channel. I didn't show you before, but there were no signaling channels in this region yet. And the device created the signaling channel. And just to kind of show you that it's working, we have this media playback viewer. And as soon as I initialize it, there's some statistics and all that that I'll show you that come out of it. But The signaling channel does take a second to initialize, but once it's connected, it's actually very low latency. So real time, I'm moving my hand kind of behind this little toy that I've got sitting at my desk. But yeah, this is just, again, the way to think about going and incorporating everything end to end so that you have really a nice low latency video feed. And the same SDKs that are being used here in this browser, we have JavaScript SDKs that allow you to kind of build this live, maybe even incorporate it into something like Amplify to go and build out your overall end-to-end applications. Like I said, there's some statistics that we can view about the video codec, the frame rate, the video resolution, the bit rate, whether or not it's using turn. And again, this is part of whether or not it's negotiating certain NAT traversal and things like that. If you know more about WebRTC, you'll understand what turn is providing for you. But yeah, that's pretty much it. The only other thing I wanted to show everybody in this is in the sample itself, and then I'll wrap this up and let y'all ask questions. And thank you for being patient with me. There is a GStreamer pipeline. Oh, that's not going to get me where I want to be. Here. So this code here, like I mentioned before, this is actually what we're working with, but we can take now any open source GStreamer pipeline tools and incorporate that as well. So something else that I'm working with is finding a way to, in the live video stream, also add like ML detect as well as draw bounding boxes around the devices or around anything that's detected in the live video stream, and have that stream live into the live video stream as well. So that would be device side, what we would incorporate there. But that's just to let you know, there are really cool things you can begin to do once you've got this working end to end. You can start to then go in and tweak what you've got in the GStreamer pipeline and start to work with things there.
But now that you have that in a Kinesis stream, could you pipe that into ML in the cloud and do analysis?
Yeah, so this is a KBS WebRTC stream, and so it's meant to be more a live stream, but there are architectures that we support, and I don't have the one handy right now, that allow us to do exactly what you described, to both incorporate ML detect in frames that are coming up. Like I could build a Lambda application that consumes the stream instead of viewing it here in the console, and do what you just described, definitely.
No, very excellent. Thank you so much.
Yeah.
Well, I guess the beauty with this is you can have 1,000 of these devices and have 1,000 streams coming in. And
yeah.
I guess you're scaling. Now, granted, I guess I wouldn't want to pay the bill on that, but or how?
Yeah.
Well, I guess you have to go to the pricing model. Whenever you ask a pricing question, you always go to pricing.amazon.com, right, to answer you.
That's right. That's right. Yep. And actually, you brought up another good point that might not be clear at first. So KBS WebRTC is really designed for more of the IoT use case, where I have a camera that I need to give access to the live stream to only a few people, like in my household or guests that come in and out. It's not designed, in my opinion, at least, for the broadcast scenario. We have AWS Elemental for that, where if you needed to think about creating a live video stream where thousands of viewers would go to one video stream, we'd probably recommend a different technology for that. But if you've got thousands or even millions of cameras and they need to each stream according to what I just described as kind of the constraints, then yeah, you'd definitely benefit from this, because that's where KBS WebRTC is meant to shine.
Would use cases for that be like security cameras in a building, or in a shop floor or a factory?
Yeah, exactly. Yep.
Maybe Starbucks stores, whatever, Home Depot, where, yeah.
Yeah, so for instance, if you've heard of Wise, they're a publicly referenceable customer of ours that they are using AWS IoT Core and Kinesis video streams. to power those things. So you can go learn a little bit more about that on our public case study. But Wise makes cameras, and that's exactly that sort of thing. Yeah, so that was it. I know I've gone over a little bit, so thanks for bearing with me as I was fumbling around with some of the configurations. But if anyone would like to contact me after this, my email address actually more formally is at amazon.com. Feel free to reach out. I can, if anything, point you to some resources that'll help you. Aside from that, we have kind of this new AWS IoT user group that we're forming a Slack community around. And you can see the URL. You should just be able to join that. There's a couple of us that are IoT specialist SAs around the world, really, that have joined this. We're starting to build a community around that to talk to each other and to, of course, encourage developers to help each other out and show each other what they're building and things like that to really, again, build with the community. And otherwise, like I already showed you, pretty much everything else that I went through today is really on this WebRTC SDK GitHub repo. And the team there is fairly responsive. So if you run into any issues, please do submit a bug report or an issue in the GitHub repo. The other thing I wanted to mention is the team is very open to community-driven pull requests. So if you have an idea, or if you have maybe a fork that's specific to some sort of device that you're working with and you'd like to see it contributed back to this repository, by all means, please submit a pull request. And if, again, it doesn't seem like maybe you need a little bit of help to get some attention on that, feel free to reach out, maybe via the Slack user group that we've got, or via my email address. Yeah, other than that, thank you, everyone. I'll open it up now, but if there's no more questions, I'm happy to wrap things up for the day.
What was your email address again?
I'm sorry, what was the question?
I think it was what's your email address?
Oh, my email address. Yep, let me put that back up.
Thank you, sorry.
Here we go. Yeah.
I tried to go to that Slack group, but it didn't seem to. It says I don't have an account on the workspace.
Yeah, just go through the normal account creation process. We don't have any special SSO or anything set up. It is truly just, we went and created a brand new Slack workspace, and we haven't gotten much further into it than that. So yeah, unfortunately, you're just gonna have to treat it like a regular old Slack account.
Oh, gotcha. I'm good. Thank you.
Yeah, okay.
Yeah, Patrick, I tried to join your Slack group, but that one seems to be restricted just to Cloudhesive and.
Oh, thanks for letting us know. Yeah, that. Every so often, the way that like open sign up on Slack works changes. We'll go take a look at that, John, so that you could do that, because we'd like for you to join. Thanks for letting us know.
I'm sure it's an Azure claim somewhere. Nope, that was a private joke between Patrick and myself.
Gotcha.
At one point, actually, before like Slack made it kind of open like that, there was like a whole hacky thing you had to do. But yeah, basically worked kind of like that, John.
I did see a question in the Slack chat, or sorry, the Chime chat from Vincent. He has a question about, he just says TensorFlow. Yes, you could use TensorFlow Lite. Actually, it just depends on what kind of GPU that your device supports. TensorFlow Lite, if you're familiar with it, you could use a CPU. It's going to come with the traditional performance caveats. But ideally, you could use something like, I'm actually playing right now with an Intel Neural Compute Stick, and that gives you a GPU that's connected via a USB port. And that, it does say it works with TensorFlow Lite. I'm still working on getting some of it to work. I think some of the nuances I'm encountering are specific to a Raspberry Pi 4, but I'm actually trying to figure that out right now. And there's a couple of other products that are out there like that today as well. All right, everyone, if there's no other questions, thank you so much for coming today. Thank you for letting me go through this. And again, if there are any pieces of feedback that you have, please do reach out. I intended on having a feedback survey. I didn't get that ready in time, so I apologize. If we could, maybe like if there's any feedback that you want to give through the meetup.com website or via my email address or via the Slack community, that I showed you, the AWS IoT user group on Slack. Please feel free to reach out there and let us know, what worked well, what didn't, and I'll look to improve this because I'm looking at doing this across a few other meetups throughout the U.S. Southeast, and also to actually have my team do this sort of thing worldwide as well. So Patrick, thank you. I'll hand it back over to you.
Oh, thank you so much. Yeah, a little slow to get off unmute here, but David, thank you so much. If you still want to get the survey URL out, feel free to just drop me or a note, and we'll get it posted. Terry, as you asked, you will get the video posted, the link to the video posted on the Meetup site as well. But yeah, again, David, thank you so much. This was extremely informative. I think IoT is something that I've not found anyone who has no interest in it. Right? It's prevalent in our lives, and the fun part about it is it's something tangible. It's physical. You could see and touch. But with that said, thank you everyone so much for joining. Again, we'll get everything posted on the Meetup. We'll get the if you're not already a member of our Slack team, we'll get the auto sign up fixed for you. And I'm looking forward to next Meetup we post. Thanks so much, everyone.
Thanks. Bye.
Thank you. Great meeting. Bye-bye.